Determine all intervals of increasing trend or decreasing trend and determine the coordinates of all maxima, minima, plateaus, or cliffs for the function f of x equals cos squared x plus cosine x. The first thing to do is find the domain. F of x equals cos squared x plus cosine x. Each term involves the trig function cosine x, which has no denominator, and all terms are in the numerator here. Therefore, the domain will be all real numbers, or negative infinity to positive infinity. Trig functions have a tendency to have an infinite number of maxima, minima, or plateaus throughout their entire domain. Nicely, cosine of x is 2 pi periodic, which means that it repeats itself every 2 pi radians. Another way to write this is f of x plus 2 pi equals f of x. So instead of working on the entire domain of negative infinity to positive infinity, what we can do is work on the unit circle interval, which starts at 0, includes it, square bracket, up to 2 pi, does not include it, round bracket, because 2 pi is the same point as 0 on the unit circle. And we can then extend the results to the entire domain by using the 2 pi periodic nature of cosine x. The next thing to do is find all critical numbers on the unit circle interval. We will take the first derivative, but before we do that, let's rewrite the function first term, cos squared x, which means cosine x squared, which may help us to find its derivative. The first derivative, f prime of x, equals, first term is power rule, bring down the power, leave the inside alone, subtract 1 from the power, it will now be to the first power, multiplied by the derivative of the inside, which is a negative sine x, plus the derivative of the second term, derivative of cosine, is negative sine x. We will want to fully factor the first derivative. There is a common factor of negative sine x. We will factor that out. It will leave behind a 2 cosine x plus 1. We can now set the numerator equal to 0 and the denominator, if there's one, also equal to 0, solve for all x's. If we have multiple factors, each one can be set equal to 0 separately. So negative sine x equals 0. We can divide both sides by a negative 1, and sine x equals 0. This occurs when x is a 0, again when x is a pi, and again when x is a 2 pi, but 2 pi is not in the unit circle interval, so we will not include that one. We can also set the 2 cosine x plus 1 equal to 0. We can subtract 1 from both sides, divide both sides by 2, and cosine x will equal to negative 1/2. Cosine x equals 1/2 in the first quadrant of the unit circle at pi over 3. To be negative 1/2 for cosine, it needs to be in the second and third quadrants, so we need the pi over 3 equivalent in the second quadrant. That will be 2 pi over 3, and the pi over 3 equivalent in the third quadrant, which is 4 pi over 3. We can now draw a unit circle interval line, a line representing the interval of the unit circle, which begins at 0. It includes 0. However, 0 here is one of our critical numbers, and therefore we are going to remove it from the interval, so it will no longer include it, so it'll be round bracket, because all critical numbers are removed from the unit circle interval. It goes up to 2 pi. 2 pi was never included. We can now split this further with all the remaining critical numbers in order. We have 2 pi over 3. The next one after that is pi. The next one after that is 4 pi over 3. This splits the unit circle interval into 4 separate intervals. We can pick a test value in each of the intervals. The interval from 0 to 2 pi over 3, which is in the second quadrant, contains pi over 2. I will choose that. The interval 2 pi over 3 to pi, which is purely in the second quadrant, does contain 3 pi over 4. I will choose that. The interval pi to 4 pi over 3, which is purely in the third quadrant, does contain 5 pi over 4. I will choose that. And then the interval 4 pi over 3 to 2 pi, which is from the third quadrant all the way to 2 pi, contains 3 pi over 2. I will choose that as the test value. We can now test the trend in each of these intervals by plugging the test value into the first derivative. We don't care about the value, just whether it is positive or negative. The best place to plug it in will be the fully factored version. Plugging pi over 2 in, working in the parentheses first. Cosine of pi over 2 is a 0, plus 1 is a positive. Outside of the parentheses, sine of pi over 2 is a positive, and then times that negative. We have a negative times a positive times a positive. That will be negative. A negative first derivative indicates a decreasing trend. Now plugging in 3 pi over 4 into the factored version of the first derivative. Cosine of 3 pi over 4 is negative root 2 over 2. Times the 2 will be negative root 2. Added to 1 will be a negative number. The sine of 3 pi over 4 is positive root 2 over 2 times the negative, so we have a negative times a positive times a negative, which is a positive. A positive first derivative indicates trend increasing. Plugging a 5 pi over 4 in. 5 pi over 4 is in the third quadrant, so sine and cosine will both be negative, root 2 over 2. 2 times negative root 2 over 2 is negative root 2, plus 1 is a negative. Sine will also be negative, and then times a negative, that's 3 negatives multiplied together. That will give a negative first derivative, which indicates a trend decreasing. And now we can plug 3 pi over 2 in to the fully factored version. The cosine of 3 pi over 2 is 0, plus 1 is a positive. Sine of 3 pi over 2 is a negative, and then times that negative 1. Negative times positive is positive. Positive first derivative indicates a trend increasing. So we have a decreasing trend on the interval 0 to 2 pi over 3. Union, it's happening again from pi to 4 pi over 3. We have an increasing trend from 2 pi over 3 to pi. Union, it's happening again from 4 pi over 3 to 2 pi. Right at the critical number of 2 pi over 3, we have a trend changing from decreasing to decreasing. That indicates that 2 pi over 3 is a relative min. So we have a relative min at 2 pi over 3. It will have some y coordinate corresponding to it, which can be found by plugging 2 pi over 3 into the original function. So f of 2 pi over 3, which will be cosine of 2 pi over 3 and then squared, plus cosine of 2 pi over 3. The cosine of 2 pi over 3 is, in the second quadrant, pi over 3 equivalent, so it's negative 1/2 squared plus a negative 1/2. Negative 1/2 squared is a positive 1/4, and then minus a 1/2, plus minus is minus, and we can call that 2/4. 1 minus 2 is negative 1/4. So this will have a y-coordinate of negative 1/4. Right at the critical number of pi, we have a trend increasing, changing over to decreasing. That means pi will be a relative max. I'm going to write it second because there is an earlier one. This one's a little bit tougher to see. But right at 2 pi or 0, the trend is changing from increasing to decreasing. And 0 was a critical number here. It just happens to be right on the border of the unit circle interval. but it is changing from increasing to decreasing, and that makes 0 also be a relative max. We can find the y-coordinates to each of these by plugging these x-coordinates into the original function. So starting with 0, f of 0 will be cos of 0 squared plus the cos of 0. The cosine of 0 is a positive 1, so this will be a 1 squared plus a 1. 1 squared is 1 plus 1 is a 2, so this will have a y-coordinate of 2. Plugging pi in to the original function will be cosine of pi squared plus cosine of pi. The cosine of pi is a negative 1, so this will be negative 1 squared minus 1, which will be a positive 1 minus 1, which is 0. So this will have a y-coordinate of 0. And then last of all, we have, right at the critical number of 4 pi over 3, a trend changing from decreasing to increasing, so it also will be a relative min. It has a corresponding y-coordinate which can be found by plugging the 4 pi over 3 in to the original function, which will be cosine of 4 pi over 3 squared plus cosine of 4 pi over 3. 4 pi over 3 is in the third quadrant and is a pi over 3 equivalent, and cosine is negative in the third quadrant. Pi over 3 equivalent means it's a negative 1/2. So it looks like this will have the same results as the 2 pi over 3 had, a positive 1/4 minus, we can write this over a common denominator and combine them together, it'll be a negative 1/4. And there is the results over the unit circle interval. To put this over the entire domain of negative infinity to positive infinity, we can use the 2 pi periodic nature of cosine. So we multiply the period 2 pi times an integer n, and we add that to all x values in the results here. Now all of these intervals are x intervals, so all these values will have a 2 pi n added onto it. For the points of relative min and relative max, only their x-coordinates will have a 2 pi n added on because the y-coordinates are resulting purely from trig functions. So we have decreasing intervals from 0 plus 2 pi n up to 2 pi over 3 plus 2 pi n, union, and again, pi plus 2 pi n up to 4 pi over 3 plus 2 pi n. We have increasing intervals, 2 pi over 3 plus 2 pi n up to pi plus 2 pi n, union, and then again from 4 pi over 3 plus 2 pi n up to 2 pi plus 2 pi n. We have relative minima happening at 2 pi over 3 plus 2 pi n, comma, we do not add on to the y-coordinate because it came from pure trig functions, and at 4 pi over 3 plus 2 pi n, comma, negative 1/4, again we do not add to the y-coordinate, and relative maxima at 0 plus 2 pi n, comma 2, we do not add the 2 pi n to 2, it's a y-coordinate, came from pure trig functions, and pi plus 2 pi n, comma, 0. We don't add 2 pi n to any of the y coordinates, where for all of this, n is equal to an integer. It can be a positive integer, it can be a negative integer, it can also be a 0, which would result in all the unit circle interval results. And this will give the entire results over the entire domain of negative infinity to positive infinity.